Every time you flush a toilet at 38,000 feet, there's a question that almost nobody asks until it's too late to unhear it. Where does that waste actually go? Most people have a guess, and it's almost always the same one. It just gets sucked out into the open sky, vaporized somewhere over the clouds, gone forever. It's a clean mental image. It's also completely wrong. And if it were true, entire neighborhoods near airports would have a very different, very unpleasant relationship with air travel. So let's actually answer this properly, because the real system is stranger, smarter, and more tightly engineered than almost anyone flying today realizes. A single wide-body jet on a long-haul route can carry more than 400 passengers for upwards of 14 hours. Do the math on how many times those lavatories get used on a flight like that, and you start to understand why this could never be left to chance or gravity or a bucket. Every part of the system, from the valve under the bowl to the tank buried in the belly of the aircraft, had to be engineered around one brutal constraint that governs almost everything in aviation: weight. Start with the obvious question. If waste isn't going straight outside, where is it going? The answer is a sealed tank bolted into the belly of the aircraft, usually near the rear. Every lavatory on the plane is plumbed into it. Nothing leaves the aircraft until it's on the ground. That's the short version. The long version is a lot more interesting, and it starts almost a century ago with a problem nobody had solved yet. In the earliest days of commercial flying, there was no system at all. Planes were small, hops were short, and if a passenger needed a bathroom, they simply waited until landing. As routes stretched longer and cabins filled with more people, that stopped being realistic fast. The first fix was almost insultingly basic: a chemical bucket bolted to the floor, sealed with a lid, emptied by hand after every flight. It worked, technically. It also meant that turbulence, tight quarters, and a bucket were now sharing the same small room, which is exactly as bad as it sounds and exactly as unhygienic as you'd expect. Engineers moved on quickly to something called the gravity toilet. The concept was elegant in its simplicity. A valve sat directly beneath the bowl, connected straight through the fuselage. Pull the handle, the valve opens, and everything drops straight into the slipstream outside. No pumps, no tank, no moving parts to fail. For a while, this actually worked reasonably well. The airflow around the aircraft carried odor away almost instantly, and passengers barely noticed. But letting waste out directly into the atmosphere created a new problem, and it's one most people have never heard of. Aircraft used a blue disinfecting fluid to break down waste and control smell. Occasionally, a seal would fail, and a small amount of that fluid, mixed with waste, would leak onto the exterior of the fuselage. At cruising altitude, the outside air temperature can drop to around minus 50 degrees Celsius. Anything wet freezes on contact. That's how you get what pilots grimly nicknamed blue ice, a frozen chunk of waste and chemical clinging to the belly of the plane. Most of the time, it just stayed there until landing, then melted away, unnoticed. But not always. There are documented cases of these frozen chunks breaking loose during descent and landing on houses, cars, and once, memorably, a garden shed. Rare, genuinely bizarre, and more than enough reason for engineers to scrap the whole approach. By the 1980s, a completely different idea took over, and it's the system almost every commercial aircraft still uses today. Instead of using gravity or water to move waste, engineers switched to air. Vacuum toilets debuted on aircraft like the Boeing 757 and 767, and within a decade they were the industry standard. Here's how it actually works. Underneath the bowl sits a valve that stays sealed at all times, cutting the cabin off completely from the waste system below. When you press the flush button, that valve snaps open for a fraction of a second. A sudden pressure difference pulls everything downward through the pipes with enormous force. That loud, sharp whoosh isn't water rushing through a pipe. It's air moving fast enough to be genuinely startling in a room the size of a phone booth. The whole flush uses somewhere around 100 to 200 milliliters of water, just enough to rinse the bowl's non-stick coating. Compare that to a household toilet, which can use 10 times that amount per flush, and you start to see why airlines love this system. Less water means less weight, and weight is the single most expensive variable in aviation. Think of it like the difference between a broom and a shop vac. A gravity toilet is the broom, relying on nothing but a straight drop and momentum to get the job done, simple but crude. A vacuum toilet is the shop vac, using a sudden controlled pressure difference to grab everything instantly and pull it off somewhere else entirely, using far less material to do a cleaner job. That's the entire philosophy behind the shift here. Do more with less, and let physics carry as much of the load as possible. Now here's the part almost nobody knows, the part that makes this whole system almost free to run once the plane is in the air. That vacuum has to come from somewhere. On the ground, it's generated mechanically by a pump creating artificial low pressure inside the tank. But once the aircraft reaches cruising altitude, physics does the work instead. Outside the fuselage at 35,000 feet, the air pressure is a small fraction of what it's at sea level. Inside the cabin, pressurization keeps things comfortable, equivalent to sitting somewhere around 8,000 feet above sea level. That gap between the pressurized cabin and the thin air outside is huge, and engineers built the waste tank to exploit it directly. The tank sits connected to that low-pressure environment, so when the valve opens, everything gets pulled toward the outside pressure almost instantly, without the pump doing much work at all. It's one of the rare cases in aviation where altitude makes a system easier, not harder. None of it, however, actually leaves the aircraft. Everything collects in that sealed tank, which is reinforced to handle temperature swings, vibration, and pressure changes for the entire flight. To stop the contents from freezing solid at cruising altitude, the tank and its connecting pipes are heated continuously throughout the flight. Sensors track how full it's getting, and if it approaches capacity, the system can lock the toilets out entirely until landing. This is also where a persistent, oddly popular myth needs to die once and for all. There's no valve lever or hidden button that lets a crew member empty that tank mid-flight over open water or open land. Every access point is external, fully sealed, and only reachable from the tarmac with specialized ground equipment. The idea of waste being deliberately dumped somewhere over the ocean simply isn't how the aircraft is built, physically or procedurally. After landing, a ground service vehicle called a lavatory cart connects to a dedicated panel on the exterior of the plane. It pumps the tank empty, flushes the system with disinfectant, and refills the small reservoir of clean water for the next flight, all within the tight turnaround window between landings, often less than an hour on a short domestic route. It's a job almost nobody thinks about, done by people almost nobody thinks. And it happens on every single commercial flight, multiple times a day, at every major airport on Earth. Airlines even schedule it into the same ground handling checklist as fueling and baggage, because a full tank grounds an aircraft just as fast as an empty fuel tank does. It's worth comparing this to how other vehicles handle the same problem, because the differences reveal exactly why aircraft do things this way. A cruise ship, for instance, doesn't care much about weight, and it isn't dealing with dramatic pressure swings or extreme cold at 35,000 feet. So it can rely on straightforward gravity tanks and, on larger vessels, full onboard treatment plants that would be far too heavy and complex to ever fit inside a fuselage. An aircraft has none of those luxuries. Every extra liter of water costs fuel. Every additional kilogram of tank material costs range. So the entire design philosophy bends toward one single goal: moving as much waste as possible, using as little water and weight as possible, while staying completely sealed off from the pressurized cabin sitting just above it. And what about the water passengers actually drink on board? It's regular potable water, loaded through a separate service point on the ground and tested for safety and bacterial content regularly. Airlines typically limit how long it sits in onboard tanks, often capping it around 3 days before a full refresh, and the potable water system is kept in an entirely separate part of the aircraft from the waste system, serviced by different equipment and, in most cases, different ground crews entirely. Tea and coffee are generally considered fine since the water gets heated before serving. Straight tap water from the galley is a little more debated, which is part of why plenty of frequent flyers, pilots included, quietly stick to the bottled stuff. There's one more story worth mentioning because flight crews have repeated it for years and it never stops being funny. New flyers occasionally mistake that blue disinfecting fluid sitting in the bowl for ordinary water, and in a small number of documented cases actually tried to splash their face with it before landing. They left the lavatory with a faint blue tint that took a shower, a fair bit of scrubbing, and a good deal of patience to fully remove. It sounds invented. It isn't. And it's a small, slightly absurd reminder of how little most passengers actually understand about the machine they're sitting inside for hours at a time. Step back, and the whole story is really about constraint. No spare weight to carry, no room for mechanical failure at 40,000 feet, and no way to just vent a problem into the atmosphere and call it solved. What started as a bucket bolted to the floor became one of the most quietly sophisticated systems on the entire aircraft, one that borrows the thin air outside to do half its work for free, and turns a problem every single passenger creates into something that leaves no trace on the journey at all. So next time that button gets pressed and that sudden whoosh fills the cabin for half a second, you'll know exactly what's happening underneath you, exactly where it's all going, and exactly why an entire industry spent a century quietly solving a problem nobody wanted to talk about out loud. Spoiler here, not the sky.